Hi guys, my name is Rangga, this is Andre, Danis, and this is Wat, and we are from Institut Teknologi 10 November, Surabaya, Indonesia. So let's talk about battery. Battery is a common thing that we mostly use to powering up our electrical devices. It is in our phone, laptop, television remote, and many more. So how this little thing can generate electricity? In general, battery convert chemical energy into electrical energy. This is what we call an electrochemical reactions. The reactions involve the flow of electron from one electrode to another. The flow of electron is what we call current, and it can be used to powering up mostly of our electrical devices. Nowadays, well-used batteries are alkaline and zinc-carbon battery. However, both batteries contain hazardous electrolyte. Alkaline use potassium hydroxide, while zinc-carbon use ammonium chloride, which according to its datasheet, both of them are harmful to the aquatic life. So we can't release them to environment directly. Based on that fact, we can say that both alkaline and zinc-carbon batteries electrolyte is not environmentally friendly. In this project, we are going to try replacing zinc-carbon batteries electrolyte with ammonium sulfate. You can find ammonium sulfate in a lot everyday application because of its unique chemical and physical properties. One of the example is you can find ammonium sulfate in ZA fertilizer. So, we can say that ammonium sulfate is more environmentally friendly. The aim of this project is to increase the amount of recyclable material with adequate performance as a commercially produced zinc-carbon battery. Before we show you how to build the battery, I just want to state that in our research days, we tried a lot of variation. We tried varying the electrolyte molarity, carbon and manganese mixing ratio, even the battery immersing time. But here, we are going to show you the best variation that we got so far. So, without further ado, let's start building the battery. Okay, first thing first, we need to prepare all the materials we need. We got carbon and manganese dioxide, and then we got our DIY battery case to hold the materials in place, copper for current collector, and zinc for our electrode. We also make a connector from copper to connect its cell of batteries. For our electrolyte, we are using diluted ammonium sulfate. After all the materials are prepared, first thing we are going to do is mixing carbon and manganese dioxide with 1:1 ratio. Make sure to mix it thoroughly. Next, we are going to prepare the electrolyte. We are diluting the ZA fertilizer until we have 2 molarity of ammonium sulfate solution. In this case, we are going to need at least 500 milliliters of it. After that, we are going to build the battery. First of all, put the acrylic battery case to hold all the materials in place. Then, we put copper as our current collector. Next, we are putting 3 grams of carbon mixture as our electrode. And then we put cotton as our separator. And then zinc as another electrode. And we are going to top it with our acrylic case and then seal it with bolt and nut. So, for a stack of battery, we are going to arrange 5 cells that we made earlier in series. To start the reaction, we are going to immerse the battery that we made earlier into our ammonium sulfate solution for about 20 seconds. After that, we are going to dry it and let it rest for about 5 minutes. After 5 minutes, we are going to measure it with multimeter. The voltage may vary from 4.8 volt up to 5.5 volt. So that's all about the process of making our zinc-carbon battery, and we are going to discuss the battery data in depth at presentation stage. But for now, we can conclude that ammonium sulfate can replace ammonium chloride as electrolyte in zinc-carbon battery. The performance comparison of both electrolyte will be discussed in detail at presentation stage. I think that's all for now. Thank you for viewing this video and see you at presentation stage. Cheers!